So today's topic is design patterns. We will be covering 3 design patterns. First is composite. Second one is observer. Third one is strategy. Okay, observer, third one is strategy. Okay, so we will be covering these 3 design patterns today, right? But before starting this, do you know the types of design pattern? Okay, so basically there are mainly 3 types of categories of the design pattern. First is creational design pattern. It will deal with the object creation mechanism, right? We have done singleton and factory, right? These were basically the creational design pattern. Okay, we were focusing on the object creation mechanism, right? How to create the object, how means the structure, right? Basically it will deal with the object creation mechanism to create the object in a way that is suitable for the situation. Okay, when to use? Object creation is complex or repetitive when you want to decouple object creation with its usage, right? And we have already done singleton and factory, right? This is the first one, creational. Second one is structural. We have done the design pattern adapter, right? Adapter we have covered. This decorator we have covered. These are what? These are the structural design pattern. We will deal with the object composition, right? How classes and object are structured. Basically the structure of the objects and the classes to form a larger system. Okay, and this is the use cases when you need to simplify the complex relationship between the objects, right? We have already done this adapter and the decorator. If you didn't see in the video, just check the recordings, okay, the previous videos. The third one is behavioral design pattern. What is this? It focuses on how objects communicate and how responsibilities are distributed, right? And when to use? When you want to basically when you want to check like how objects are communicating with each other, right? So it focuses on that thing. When you want to improve how objects interact and cooperate, when you want to make behavior flexible and reusable, when you want to encapsulate algorithm or the action. So today we will be checking this strategy. We already done this. Observer is done. No, we will cover today, right? And what else? Yeah, so we will be covering these pattern today, that is behavioral. Okay, so let's start with the first one, that is the composite design pattern. What is the definition? It says it is a structural design pattern that let you compose objects into tree-like structure. Okay, this is important. Composite, we can say tree-like structure. Okay, like structure. Okay, what does that mean now? To represent a part-whole hierarchies, it allows clients to treat individual objects, that is the leaf nodes. Like in the tree we are having the last node as the leaf node, and compositions, that is the composite nodes, the intermediate, the middle nodes. Okay, so how we can check this? Let's see the real world scenario. We are having the file system, right? Files are the individual leaf. Let's say we are having one folder is there, let's say root. Okay, after that we are having 2 folders. Let's say this is for documents, this is for pictures. Okay, inside that we are having the files. Here is the file, let's say picture 1. Here we are having the documents, document 1, document 2, right? So here these are the leaf nodes, right? These are the leaf nodes, and we can say these are the individual leaf. Okay, great. Otherwise, what else? What are these? These are the like folders can contain both the files and the subfolders, right? These are composite. Okay, compositions are there. Great. This is also composition. So what we can say, this composite can have the folders as well as the files, right? We can have a file here also. Let's say one file is there in the root. Great. So this will be the flow. So this is the structure of the composite design. Okay, this is the structure based design, right? So what is the intention? Treat both simple and the complex element in the same way via common interface. Okay, let's see. We will be having a component interface. So leaf will be implementing this interface, as well as the composite, the folders also implementing the same interface, right? Let's see the code for this folder. Okay, folder. See, here is the role. This component is what? Declare the interface for all the objects. Either it's a leaf, either it's a file or a folder or composite, right? Leaf, this is the end object, the last node. It cannot have the children. We can say file. File is the leaf node. Composite means it can have the children and implement the children related operations. That means add or remove, right? We can add the file, we can remove the file from the folder. Great. Now client, it will work with the components uniformly through the interface. This will be the main method. Let's see the this is the use case. Basically we will check this afterwards. Okay, let's see the example of this file and the folder, this structure. Okay, now this is the structure. We will be implementing this structure in our code. Okay, so first thing we will be having here, what we are having the component, the common interface for both file and the folder, right? So let's implement this, the common interface file system component, and we are having one method, abstract method, that is what? Show detail. Okay, show detail will be there for file as well as for the folder. Now leaf implementation, the last child, or we can say what? The file, right? If you see the structure, what we are having in the structure, we are having this interface. After that we are having the implementation of leaf and composite, right, separately. And inside this composite we can have the list of the component. Okay, either it can be the leaf or it can be the composite. Let's copy this also. Okay, so here you can see, right, what we are having. We are having first the component, the common interface for both file as well as the composite, that is the folder, which can have what? Which can have the, again, what is the definition of this component? Component is the interface which can have the leaf and the list of component. What is component? Component is the interface which can have what? Which can have the leaf and the composite, right? The further folder, again, what is this? This is the folder. Again, it can have the file as well as the subfolders, right? And this is the composite. Again, it can have what? The leaf, the subfolder, right? This is a tree like structure, right? Tree like structure. Okay, so we will be implementing this. Now we have implemented this common interface which is having this show detail method, abstract method. Now implementing this leaf implementation. Okay, so file, class file is the leaf node that is implementing this interface, implementing file system component. In the file, what we can have? We can have the name, right? Name is there. Using constructor, we can put the value of this name, right? After that, we are having the definition, the implementation of this show detail method. Okay, file and the name of the file. Simple, right? Second thing is, this leaf is completed. Now we will come to this composite. Now composite can have the list of component, right? So first thing, it will have the name of the folder, right? Name of folder. Second thing, it can have the, again, it can have what? It can have the leaf as well as the composite, right? So we can say it can have the list of component, right? So list of what? This file, system, our interface basically, file system component, right? Component, these are the children for this, right? Children, this is the array list, new array list. So second thing, we will have the list of the components, right? So let's use the constructor injection, putting the name of this folder. After that we can have what? This folder can have the basic methods, let's say add the file, remove the file, or remove the folder, right? Basically adding or removing the composites, the components, right? So in the add, what we are doing, we are passing the component. It can be file, it can be composite, right? It can be file, it can be what? Composite, right? In the folder we can have the file, we can have the sub folder. Great. So as a children we will add this, right? Let's say here we are adding a new leaf, right? New leaf. Or let's say here in the root we are adding this pick, right? So how we can add? Using this method. Okay, we will be passing this pick folder and we will be adding this here. Okay, or you can see the example of only this thing, right? What we are doing, let's say this is the folder, we are adding file. Okay, this will be the component, we are adding it in the pick. Great, using this code. After that we can also remove this. Okay, we can remove the component, just removing from the list, adding to the list. Simple operations, right? Now in the show detail we will be having a show detail, right? What we will have? The folder name we will be having and the children, right? Let's say if we want to check the description of this, what we will have? We will say we are having root. After this we are having one folder pick, one folder doc, right? After this what we are having? We are having the for this pick we are having a one file, right? And for this doc we are having two files, right, with their name. So what is happening here? What is happening here? Anyone? What is happening here? How we can check it? We can basically get the details for all of the nodes. Basically what we are doing, we are simply traversing the tree, right? Traversing the tree, right? Great, we can do it using recursion, right? So we are using the recursion. Understood? So how we can traverse this? Let's see here. Let's see in this show detail what we are doing. Let's say we have started with the root. Okay, root will be there. Root. Okay, first root will be printed. Great. After that we are having the for loop for the children of this root. What are the children? Pick is there and doc is there, right? So first let's say it will print what? It will print the C show detail, means it will call this method again recursively, right? Okay, so C was this pick. Okay, we call this method again for the pick, right? So again we will get the folder name as pick. Great. After that again it will check the children of pick. Now again it will call it recursively. Again we will get the children, that is what? That is this file 1. Okay, we will get file 1, right? After that there is no folder, right? There is no children for the pick, so it will go back to the pick. Again it will check if there is some other children using this for loop. It's not there. Again it will go back, right? Go back to the root, right? Now when it is at the root, it will check for the second child using this for loop, right? We have traversed this for loop, and when we got the pick, that is the first child, we called it recursively. Now this recursion is completed. It will call for the second child, that is this one, doc, right? So we will call for the doc doc is printed. Okay, doc, for the doc we call this show detail, right? Again it will call for the this for loop, the children of this, that is what, file1, let's say file2 for this, file2, right? It's again it will go for the file2, nothing is there, it will come back to the doc, it will call for the second child, that is f3, using this for loop, right? When this is also completed, nothing is there, right? In the child of this f3, nothing is there, it will go back to the doc, right? Now doc also is completed, there is no further child, again it will go back, right? Again for the root, nothing is there, no more child, so we can say it's completed. Our recursive call is completed. This is how we will print it. So this recursion is clear, right? Recursion is clear. This will tell the format how we will print it, right? Okay, now next part. This part is clear. This composite implementation is clear. Now we will be having the main method, how we will call this, right? We have seen the leaf node implementation, the composite implementation, right? In the leaf node we will be having simple what, show detail method. In the composite we can have further childs, right? So list will be there. We have seen this, right? We have seen this. So list will be there. After that we will be having some basic operations. Let's say add file or subfolder, remove the file or subfolder, right? So these things. After that we are having this show detail. This will be the recursive, right? We have seen the example here, right here. So in the glide code, let's see the main function. What we are doing, first we are creating f1, so let's create it. F1 is created. This will be the leaf node, right? Because this is the individual object. Second thing is f2, right? So f2 is created. Again this is the individual. After that we are creating one folder docs, right? And we are adding this f1 and f2, right? So it will go here, and add what, f1 and f2. That is the type of file system component, right? New file is what, new file is implementing this file system component. Great. So we will be adding f1, we will be adding f2. After that we are creating one more file, f3. Okay, that is a photo. Okay, now after that we are creating one folder pic is created, right? After that we are adding f3 in the pic using this add function. Okay, it's expecting this file system component type, and we are passing the same, right? This file is the type of file system component because it's implementing the interface, right? The interface is common for both composite and file. Great. After that we are creating a root. Folder, that is the parent folder for all of the folders. And after that we are adding the docs. We are adding the pic in this. Okay, great. So this is how we will be using the same method, that is add, for adding the file also, for adding the doc also, because they both are implementing the same interface. After that we are calling this show detail, that is a recursive function we have seen above. Okay, so this is the composite pattern, that is the tree like pattern. Okay, so this is the composite pattern and this is the output. See, first we are getting this root, then we are getting the document folder, that is the type of this, that is the child of this root. Okay, after that we are getting this resume and the file cover, right? So we are going to through the recursion. Okay, when this is completed it will go to this pic. So same is happening, when folder is completed we will go to the pic. Okay, so these are the benefits of the composite. Okay, treat individual and composite object the same way. We are having the same interface for the both. client doesn't need to know the exact type. Okay, easily build complex tree of object, right? Open and close principle. We can add a new leaf composite class without changing the client code, right? Open to extend, close to modification. And these are some drawbacks you can check. Okay, so difficult to restrict the component only to the certain types, can get expensive or deep in larger trees, so this can be a drawback also.